In this video, I want to share how I built a fully automated system for filling the freshwater tank on my sailboat Naseem. So when the tank is full, it automatically shuts down the filling valve and also gives me a visual alarm through a red light and audible signal through a buzzer. Currently, when I'm filling the water tank, I have to lift the floorboards up and keep an eye so the water doesn't overflow. This is how the complete system looks like. I'm gonna go through one step at a time with each component and show you how I built it. So let's put this picture aside for reference and start building the system one piece at a time. I have 3 water tanks under floorboards of my sailboat. I fill them using 12-volt solenoid valves. To monitor tank fullness, I am using a liquid level sensor which is capable of detecting water through plastic or fiberglass walls of up to 2.5 inches thick. And for a visual and audible alert, when the water reaches the sensor's mounting point, I am using a red indicator light paired with a buzzer. At the heart of the system sits a marine-grade 5-pin relay switch, driving all the logic behind the scenes. Power for the entire system comes from Naseem's 12-volt DC house battery bank. Let's begin the wiring process. All ground leads run to a shared ground bus bar, and that bus bar connects back to the battery's negative terminal. For the load connections, pin 87 powers the water inlet solenoid valve, and pin 87A handles the tank full alarm. Both of these load side connections operate in a mutually exclusive manner, so only one can be active at any one time. Next step is to connect the plus 12 volts power side of the system, bringing in the main supply that will feed the relay and its connected circuits. The rocker switchboard has 5 switches, and using the appropriate fuses as shown, I start by powering the water level sensor first. Switch 1 controls the entire system, acting as the master power switch for everything that follows. At this point, the tank sensor is fully operational and works perfectly for exposed tanks. However, the water tanks on Naseem are tucked away beneath the floorboards, so I need to extend the system or the setup to create a fully automated monitoring system. Next, I connect the 12-volt power feed to the relay's load side, which is pin 30, supplying the main input that the relay will switch between the 2 circuits. Pin 87A is the normally connected output, so as soon as pin 30 receives power, the red indicator light and buzzer switch on immediately. This isn't the behavior we are aiming for yet, but that's simply because the sensor signal wire has not been connected to the relay's coil side. To complete the wiring sequence, I connect the sensor's yellow signal wire to pin 86 on the relay. When the sensor does not detect water, this yellow wire sits high at plus 12 volts, therefore energizing the relay coil and causing the load circuits to switch over to the opposite sides. As a result, the solenoid valve receives power and opens, allowing water to flow into the tank, while the red indicator light and buzzer remain off. Now I wait for the tank to fill. As soon as the water level reaches the sensor's mounting point, the yellow signal wire drops low, essentially becoming ground. The relay coil is de-energized. The load side of the relay shifts positions and pin 87 loses power, which closes the solenoid valve and stops the flow of water. At the same time, pin 87A becomes active, bringing the red indicator light and buzzer on. Now the tank is full, and I shut the system down using the main switch number 1. Well, okay, I've assembled all the components as planned. The light and buzzer joined up together to become one unit. Negative bus bar to connect all the negative ground joins. The main system, the heart of the system is the relay and the buzzer. Now of course my solenoid is on board my boat, and that's where I have a switch. So I'm gonna connect them all. Okay, all connections have been made. All the ground are going to the common ground, and then to battery's negative terminal, and buzzer signal, power to my sensor through a mini fuse, power direct to relay. Right now I'm just using one switch for my system. These will be for my other sensors and relays. They are not connected right now. Power to the whole system. So let's see. This is the sensor. You can see there's a small LED, but because it will be under my floorboard, so I do not know. Imagine that's my tank. So the idea is the water tank is filling as an empty level. Water is rising. As soon as it detects the water, comes up. So when it comes up, I just need to enter the whole system off.